Hello class, welcome to the lesson of New Energy Vehicle Motor and Control System Maintenance. Today we are studying the significance and limiting factors of regenerative braking. First, let's take a look at the development of regenerative braking systems. With the increasing prominence of environmental protection and new energy issues, the air pollution caused by traditional cars is becoming more severe, and the issue of oil shortage has gained attention. To address energy saving and environmental problems, the government strongly supports the development of electric vehicles, which are considered ideal alternatives to traditional cars. Electric vehicles have advantages such as pure energy source, sustainable zero emissions, and low noise. At the same time, electric vehicles can achieve energy recovery through their own drive motors. Aligning with our country's future environmental and economic development strategy, the regenerative braking energy recovery system was initially used in trains, and later some scholars applied it to cars. As early as the 1970s, scholars from the University of Wisconsin, such as Norman, started researching regenerative braking systems for cars. In 1979, Danish researchers conducted a detailed study of regenerative braking energy recovery theory. In 1997, Toyota introduced the Prius hybrid powered sedan with regenerative braking function. The recovered energy can provide 5% to 23% driving force for the car, thereby improving the fuel economy of the car by about 10%. Next, let's look at the significance of studying regenerative braking energy recovery. In electric vehicles, under the current condition, where there are no major breakthroughs in electric vehicle battery energy technology, recovering braking energy in electric vehicles can improve the energy utilization efficiency and increase the driving range of electric vehicles. The combination of mechanical braking, friction braking, and motor braking can reduce the wear of mechanical friction brakes, prolong their service life, and save production costs. 3. At the same time, it shares the braking intensity of traditional brakes, reduces the heat generated by braking under heavy operating conditions, lowers the temperature of the brakes, improves the ability of the braking system to resist heat decline, and enhances the safety and reliability of the car. Thirdly, let's take a look at the components of the regenerative braking system. The electric vehicle regenerative braking system mainly consists of an energy storage device, a reversible motor, and a power transfer circuit. The regenerative braking system of an electric vehicle mainly includes two parts: motor regenerative braking and traditional hydraulic friction braking. Regenerative braking can recover braking energy and provide partial braking force to the wheels. However, the effectiveness of regenerative braking is limited by motor characteristics, battery speed, and other conditions. It cannot independently meet the braking requirements during emergency braking and high-intensity braking. To ensure the safety of the entire vehicle's braking system, traditional hydraulic friction braking should be used as an auxiliary in addition to regenerative braking. Finally, let's look at the factors that restrict energy recovery in electric vehicles. In general, factors that affect the effectiveness of energy recovery during braking in electric vehicles include energy storage devices, braking force distribution ratio, drive type, motor performance, and driving cycle control strategies. First, let's look at the driving cycles. Driving cycles have the most direct impact on energy recovery during braking. If an electric vehicle drives on congested city roads, With frequent starts, accelerations, and decelerations, there will be more braking cycles, increasing the number of regenerative braking cycles and improving energy recovery. If an electric car is driven on a highway, there will be fewer situations in which braking is required to reduce the speed, resulting in less energy recovery through regenerative braking. Storage battery. Common battery storage devices used in electric vehicles include storage battery, fuel cell, supercapacitor, flywheel battery, and so on. Among them, the most common is the storage battery. Therefore, the condition of the battery should be fully considered during braking energy recovery. If the SOC of the battery exceeds the upper limit value during braking, it indicates that the storage battery is sufficiently charged and doesn't require further charging. At this time, it is not easy to perform energy recovery during braking, as it may damage the storage battery life and potentially pose safety issues. Additionally, to protect the storage battery, the maximum charging current and power that the battery can withstand should be fully considered. During braking energy recovery, motor as a key component of regenerative braking system. The better braking ability the motor has, the higher the proportion of regenerative braking force can be allocated over mechanical braking force, thus enhancing the effectiveness of energy recovery during braking. In addition, the electrical efficiency of the motor also has a significant impact on energy recovery during braking. Moreover, it is not favorable for the motor to perform energy recovery during braking in low speed and high speed scenarios. The greater the braking torque that the motor can provide, the more braking energy can be recovered. The regenerative braking torque of the motor is constrained by the generator power and speed. When the braking intensity is too high, the motor cannot meet the braking requirements. Control strategy is the software core of electric vehicles. To improve energy recovery efficiency with regenerative braking technology, a reasonable regenerative braking control strategy is needed. The most critical aspect of the regenerative braking control strategy is, under the premise of ensuring braking safety, the optimal allocation of regenerative braking force and mechanical friction braking force between the front and rear wheels, maximizing energy recovery, and optimizing driver experience. Driving types. From a vehicle model perspective, the most researched type of electric vehicle is currently the dual-motor electric sedan. However, whether it is a dual-motor electric sedan as a two-wheel drive or for a four-wheel drive, the energy that can be recovered during the braking process is only the kinetic energy from the driving wheels, while the kinetic energy from the non-driving wheels can only be dissipated through heat generated by mechanical friction braking. Therefore, under the premise of ensuring braking safety, allocating as much braking force as possible to the driving wheels is beneficial for improving braking energy recovery efficiency. That's all for today's lesson. Thanks for watching.